Hello and welcome to the speech part of the lab course on deep learning. So, 4 weeks of text processing would have been done, and now for the next 4 weeks I will be dealing with the speech part of the deep learning process. So the speech technology essentially is only involved with what you speak, and that is very different from the text that you have been learning about for the past few weeks. Okay, so what is speech? Why is it so different from text processing? So for example, the first thing that you do is when I speak, I am actually generating some kind of a wave, which is compression and rarefactions in the atmosphere, and usually we record that, and on the microphone, when you record it, it's actually a continuous time signal like this. Okay, so this is the speech signal, and what we want to do is essentially use this signal to do something better, right? Often it's very difficult to see what the speech signal is doing, simply because you cannot visualize the waveform. Okay, on the other hand, text is very easy to understand because you actually see the visual representation of the text, right? So text is made up of, for example, if you're talking about English, you have the alphabets A to Z, and words are created by concatenation of these alphabets. Okay, on the other hand, speech is not that easy to visualize, and therefore the understanding of the speech technology itself makes it a little more difficult to do things. Okay, so in this, for the next 10-15 minutes, I'll give you some broad overview of speech technology. I assume that some of you may have done a course on speech technology before. Even if you have not done this part of the course, you don't need much. I'll try to give you some background for the next 10-15 minutes, and you can learn from that and proceed. Okay, so as I said, speech is very different from text. One of the reasons is speech is something that we normally do it in everyday life, right? So we speak, and the purpose of speech is communication. Okay, so therefore, when I'm wanting to say that, do you want me to join for lunch, right? I want to go for lunch. I create that message in my brain, and then I can formulate that question or formulate that message in many different ways, right? If I first have to choose a language, so I might say something like, do you want to go for lunch? That's perfectly acceptable. Or lunch, just a question like that. That itself is good enough for you to understand that I am asking a question, lunch, right? So that even the pitch variation in voice makes it a question rather than a statement, lunch, right? Lunch, right? So there is a difference between what I say. Okay, or you can say in some other language, you can even code mix, lunch jana hai kya? So if I want to mix English and Hindi, which normally we do in urban India, so lunch jana hai kya, or lunch sapalama. So that's in Tamil, right? So there are many ways that I can communicate this message, and you as a receiver then process this particular signal when it reaches a ear, and then there is some processing done by the ear, and then it sends to the brain, and then you get the message, okay, I, Umesh, I'm asking you, do you want to join for lunch, right? That is the message. So the purpose of speech is always communication, correct? And speech was one of the ways that we communicated when we evolved as human beings. Text came much later, right? Text came, one of the reasons text came is that when I speak, obviously the speech signal dies, within a few meters, right? So even if you are in the few rooms away, you will not be able to hear me. Even I have to shout, and beyond a certain point, even if I shout, you will not be able to hear until the technology like wireless technology came, which basically, or antennas came, which basically could transmit these things over long distances, right? But that is a totally different a new technology. But in the after speech, when people wanted to send the message to long distances, suppose one king wanted to send a message to another king, that's when the idea of text came. And so you wrote something in a piece of paper, I mean a cloth or something, and then a messenger took it across to the other person, right? So that is when text as a medium for communication evolved, okay. But speech is much more fundamental. We started speaking first, right, and therefore we do it very, very effortlessly, both the speaking part and the understanding or listening and understanding what is the speech aspect of it. Speech is also very different from audio or music, in the sense speech has a very different structure, and often it can be modeled very well with some simple mathematical models, whereas audio is much more difficult to model in a very sparse kind of mathematical representation, and that richness that you hear in audio, or you get in audio which is not easily modeled, is the reason that you find music very often very pleasing, because the harmonics are there and they are not easily, you have to actually capture all those harmonics to understand or appreciate music, right. So speech and music themselves are a very different aspect. So we will specifically talk about speech, and as I keep mentioning, the primary purpose of speech is to communicate, right, to send a message across. So one of the easiest ways to visualize the speech versus text communication is if you look at handwriting, right. Speech and handwriting are very close relations to each other. So if I am doing speech processing, right, versus handwriting recognition, these are very good ways of understanding speech technology, because handwriting is something that you can actually see with your eyes and therefore interpret or something. I don't know, I'm randomly writing something. This is a Bangalore doll or something. I just thought of something, okay. So this is cursive handwriting, and so you can see that when I'm writing it in English, there is a distinct space that I leave between words, right. So there's a space that delimits words, right. So between two words I leave a space, and that helps me identify the boundaries of a word, okay. So each one of this is a word, right, in English language, right, and each of these words are themselves made up of some smaller units which we call the alphabets, right. So the alphabets are the building blocks, and in English it is basically A, B, C all the way up to Z, okay. And then of course I have the numbers and punctuation and so on, but generally if we talk about in English, this is basically what we are doing, correct. And so this is very important, okay. Now in speech, fortunately you cannot see it, but and another thing in handwriting, sorry, I don't know what I did, but okay, 1 minute. Yeah, the other aspect in handwriting is I'll write in another language, let's say Devanagari. So this is मैं घर जा रहा हूँ, okay. Hindi is not my mother tongue. I don't know if this is correct, but this is just to illustrate. Again here I am using space to delimit the words, okay. But now my lipi or the way I am writing is very different from English, right. So Hindi is usually written in Devanagari script, okay. But this also has some constituent alphabets, right. So you have A, E, E and so on, and then K, K and so on, okay. Or I cannot write in Tamil very well, but in Tamil I think this is how A is written, okay. So this is Tamil's A. So these are the alphabets in Tamil alphabets, and you have Hindi alphabets, okay. So similarly, the amazing thing about speech is that speech has some basic units called phonemes, okay. And just like every word, written word is made up of the Hindi or Tamil alphabets depending on my choice of language, here these phonemes are used to build words. So phonemes are like the spoken alphabets, and when I speak, when I say the word good or something, okay, this it corresponds to the sound g, oo and d. Okay, this is the sound g. The equivalent I think will be in Hindi like g, and then this will be like oo, and this will be like d. Okay, good. That's how you pronounce g, so these are the basic spoken alphabets of phonemes. So similarly in spoken language, just like in written language, every word is formed by actually a sequence of basic sounds which we call as the phonemes. Just like in written, the basic sounds, the basic written characters are the alphabets. Okay, so and fortunately every language has this common set of alphabets, and therefore there are about, each depending on the language, you can have anywhere from 45 to about 60 phonemes. Okay, so the phonemes are somewhat shared across languages. So the sound a, whether I speak in English or Hindi or Tamil, is somewhat similar. Okay, we assume that the same representation exists, and similarly oo or e and so on. Okay, so the way you can think of it is, if I am talking or writing in English, okay, or Spanish, right, or German, okay, all of these languages have basically what we call as a Latin script or the Roman script, and therefore we all have this A, B, C kind of thing as the alphabets, which is true in Spanish also, in German also, but in some cases German might have an additional some alphabets like umlaut, and you can have some a, right, with a hyphen, which sort of a slightly different sound. So the way you write these special characters, they look like English, they look like e, they look like oo, but what is important is that they all share some kind of an alphabet, and that is typically true of spoken languages. Across all languages in the world, we share the phonemes. Some languages might have more, some languages might have less. Okay, and therefore this is like the umlaut and so on. So the phoneme representations are what we use to actually identify from the speech signal the phonemic representations, and from the phoneme we create words, from the words we create sentences, and that is the basic idea. And sentences in different languages have different kind of ordering of the words, and that's what we call as the grammar or the language model. Okay, so this is a background for speech. Now compared to speech and text, which is little more informative, you will when I ask this question, what I am asking is, suppose you listen to somebody, I'll give an analogy, right. So let me let me go to the next page. Okay, suppose this is a waveform of the same thing. I don't know, I made a sentence just now, right. This is a speech signal that I have recorded over the microphone. Okay, and the statement is, I am going to Bangalore. Okay, and I can also have the handwritten word, I am going to Bangalore. Okay, now if I showed you the text part on the right hand side, this one, and I showed you or I played out the audio to you, the message that I am communicating, you will get it, right. If you listen to the audio and close your eyes and the audio comes as, I am going to Bangalore, you pretty much know the message was, I am going to Bangalore, and it is also the same when I read the text. Okay, but speech has some additional pieces of information that you probably unknowingly or knowingly never realized. Okay, one of which is, even if your eyes are closed, you can quickly identify what the gender of the person is. A woman could have said the same thing, I am going to Bangalore, but when the woman has written I am going to Bangalore, it's from the only the written text you cannot find out whether, I mean, the handwriting experts will have some idea, but it's not very easy. And if you make this, convert it using an OCR to an editable text, right? So then even that is basically lost. Okay. So when I convert it to an electronic form which says I am going to an editable text, the handwriting variations that change from person to person, even that is lost. Therefore, when you close your eyes or read a text and close your eyes and listen to a audio clip which says I am going to Bangalore, there is some additional information. I know for sure what the gender of, to great probability I can tell it was a man or a woman, right? I can say much more information. In fact, you can sort of guess, children, obviously children's voice are very different. You can find out if it was a child that sent the message or a man or a woman. And even if I know it's a man or a woman, I can also approximately get some idea of the age of a person, because as you age, the voice changes. So an elderly person, a senior citizen's voice will sound slightly different. You can actually figure out that it is somebody beyond 50 years who's saying something as opposed to somebody who is a 22-year-old. Okay. So this idea of age group also is something that you can capture, which is not conveyed in the text. Okay. I can go one step further. I'm going to Bangalore. If I had said that, then you can see, and that if I written the same thing in text, at most I might have put one exclamation mark. This is an additional information where you convey some kind of a excitement or something in the voice. But I'm going to Bangalore could mean many more things. For example, it can go with a statement. I'm a father, right, and my child is saying I'm going to Bangalore, right? You can, without the gestures itself, you can understand that the parent is saying please do not go to Bangalore, but the child is insisting I am going to Bangalore, right? So there is much more information. There is a kind of a rebellion that's happening, and insistence that, stubbornness that I want to go to Bangalore, that is getting conveyed, which is not very easy to convey in text, right? So there is an emotional aspect that gets captured in speech that's often not very easy to capture in text, right? Then as I said, or even you can say handwriting, right? For example, as I said, I can also get the information about the gender, I mean about the language in handwriting, that we often detect through the script, right? Or if I'm writing it in Roman, like मैं घर जा रहा हूँ, right? मैं whatever it is, घर जा रहा हूँ. It sort of, if you know the language, it's very easy to find out. But otherwise, you cannot easily, with the Devanagari script, it's easier to capture. Again in speech also, by just the voice, the audio signal itself, I can sort of figure out the language that is being spoken. Okay. I can also find out if the person is slightly, I mean right now I have an allergic cold, so you can figure out that I have some issues in my speaking, my nose is slightly blocked maybe, or some respiratory issues might be there. So sometimes the speech signal itself is useful to capture some underlying respiratory or nasal issues. And actually during COVID, voice or speech was often used. There are some machine learning techniques that sort of could detect as a first level whether there's an underlying respiratory issue, so that you immediately can attend to that person. Okay. So so there are many things that you can do in speech, because it's a much more richer signal. It carries a lot more information, and I can even identify different speakers. So it's like a voice biometric, right? I can, even if it's a male person, I can understand whether it is if it's from a known circle of friends, I can identify without even on the telephone. I cannot see the person, or I can say this is Ram that spoke, or that is Henry that talked to me, or this is Mary, or whatever it is, right? Or Venkatakrishnan, whoever it is, I can easily identify the person if from the known circle. Otherwise, I at least know it's somebody, even if I don't know the person, but if I repeatedly hear the voice, I can sort of even though I can sort of place, okay, this is the person that I met in the bank right? And it is, even though I don't know him personally, even when I speak over the telephone and he says, "Aapka passbook, your passbook is updated" or something, I know this is a person I met in the bank, right? So even within a short span of a few minutes, you can sort of categorize and use his voice as a biometric in your brain, so that when he speaks next time, you sort of can identify who the person is. Okay, so there are many things that you can do in speech. Okay, and it's quite powerful, and therefore in this 4 weeks there will be 4 experiments that I will do, and those 4 experiments that I want to do is at some level a very high idea. Okay, you will not actually build, it is too complicated a field, but we want you to get excited about this field and play around with it. So we will give you some simple kind of 4 experiments, right? Each one trying to give some aspect of the speech signal, how it is exploited to do a particular task, and then you will be able to innovate or do something more creative with the kind of sample codes that we will be sharing with you. Okay.